Hello, I'm Tom. I work at the DistriNet research group, like across the street, and I'm a PhD student there in my last year, although I've been in my last year for a couple of years now. So I work on web security and privacy. Okay. Well, I will first give a broad overview of web security, like the history, evolution, and the possible future, and then I will go into some more technical things related to web security. So, well, the web was created many years ago, probably before I was born, and well, the primary design goal of the web was, well, to have people across the world be able to access static information. So it turned out to be quite a success, and it's had many different evolutions over time. So from this static information retrieval, the web became very dynamic. So websites are serving dynamic content. They are dynamically generated and so on. At first, well, to access publicly accessible content, we did not need any authentication. So then some people thought, okay, let's add cookies. And cookies get sent along with requests, and they allow users to be authenticated to websites. Then a lot of the computation of how web pages are rendered also get moved from the server towards the client. So it's possible for a client to have an entire framework that creates the web pages, just by content search from a website. And of course, to allow many new features on the web, they had to create a lot of new web APIs. So there's a lot of things that have been changing. So for instance, well, we now have JavaScript in the browser. So with JavaScript, anyone can run any type of JavaScript code in the browser. So what could possibly go wrong there? And so cookies were designed to be included in all the requests. And again, what on earth could possibly go wrong if we do this? So the web has evolved in terms of features, and these features allow for new use cases. So for instance, if cookies were never proposed or developed, the web would look very different today as it is. And well, when these features get added, I think that the main reason for this is that it allows websites to design new things. So for instance, cookies, it's obvious that without it, it wouldn't be possible to have some kind of authentication. And when these features are designed, people don't always consider all the cases. So for instance, I think with cookies, at first they might be used to allow a user to indicate that they want the website to be served in a certain language. So then it could have been just a cookie, such that, well, it holds the language preference of the user. But then it kind of evolved towards also containing the authentication tokens of the user. And well, because of this evolution, there were new issues that arose. Also, at first, these issues may not be significant because there are not use cases present yet at the time of design that make it significant. But as the web evolves, the issues may become more and more significant. Then another thing that makes web security quite, let's say, special is that as soon as a feature gets launched on the web, it's very, very hard to take it out or to change it. Because as soon as it gets implemented by the browser and used by websites, many websites start using it. So then if a browser would decide to take out this feature or to change it, it would break a lot of websites. So users who are used to interact normally with websites, suddenly they see that they cannot interact in the way they used to. And well, this might cause them to switch browsers, which is not good for the browser vendors because then they lose some market share. And well, to add new features, it's very difficult to make them future-proof because we don't know how the web will look like in 10 years or 20 years and which other features get added. So it might be that one feature on its own does not cause any issues, but when we add other features, then the combination of these different features may cause certain issues. So all these things kind of make the web security a whack-a-mole thing. So we introduce new features, these features introduce new issues, and then we can't take out these features to fix these issues, but instead we need to add even more features, so web security features, such that we can prevent these features or make them less exploitable. These security features are mainly added by adding more request and response headers. So there's a lot of different security headers. Most of them are response headers, so they are set by the server and then enforced by the browser. But some of them, especially in the next 1 or 2 years, there will be more requests headers, which allow the server to make a more advised or smarter decision on what to do with a certain request. And there are some efforts to have security by design. So a good example there is trusted types, which is a very, very new feature. I believe it's implemented to some extent in Chrome, but the other browsers don't support it yet. And it's used, like if you, instead of using plain JavaScript, you use trusted types, then your codes by design will be protected from DOM-based cross-site scripting vulnerabilities. And there are also some features that are being added, such as, many web security people really hate web cookies because they are horrible by design, at least for security. So they're trying to make a new type of or change cookies, and there's a proposal called the HTTP state tokens, which is basically cookies, but how cookies should have been from the beginning. So instead of the server setting the value for the client, it will be the client generating a certain token and sending it to the server, and it will only send it to secure connections, and it will not be accessible from JavaScript. So that's all features that the cookies don't have. And it's also non-persistent by default, which for security purposes is also for privacy purposes is also nice, because if someone wants to track a user using these HTTP state tokens, then they will have to declare it explicitly. so that it's more obvious that this is a long-term token. But, well, on the downside, there are still many new web APIs being added to the web. And often these new APIs cause some issues that are unexpected or unintended. So for instance, there's the portal element, which is in the process of being added. And I think last week or the week before, there was a talk about this new HTML element, discussing like several major features, several major vulnerabilities that, well, have been considered before and were like fixed before, and this new element reintroduced many of these issues. So, well, hopefully the implementation of this element will still change, but it's just as an example to show that new features cause many new issues. And also a nice thing, or one of the nice things is that some browsers are planning to change the way that certain features are working at the moment. So for instance, Google Chrome and I believe Firefox will follow suit there, is going to make cookies have the same site attribute by default. So this means that cookies will only be sent into requests going to the same site. So this is good for security because it prevents a lot of cross-site attacks. And what these cross-site attacks mean, I will go into more detail later. And also for privacy, because same-site cookies are not sent to trackers by default, but if trackers want to make the cookie being sent to them in a third-party context, then they will have to change the default behavior, which makes it more obvious that they are doing some sort of tracking. So web security is, for a large part, it's about the vulnerabilities that exist on the web platform. And these can be, can be classified in two main categories, or at least I classify them this way. So there's the server-side attacks, and in this attack, the attacker directly interacts with the server and tries to obtain some information from there, or cause some issues with the server. And the other category is client-side vulnerabilities. So there the attacker launches some JavaScript code or does some other things which will trick the victim into interacting with a certain target server or target website in an unexpected way. So this looks like this. So on the left side we have the server-side attacks where the attacker just interacts with the server, and then in the client side the attacker will run some code or do some operations in the victim's browser which will trigger certain interactions with the server. So there's many of these issues. This is a list of some of them, so it's not a complete list. So I made way too many slides, and I have slides for the issues or to discuss the issues that are underlined. The ones that I will be talking about kind of depends on the audience. So there are some more basic ones like SQL injection, which is a relatively well-known thing within the web security group, but I'm not sure how well the people here know about SQL injection. Maybe some if you have heard about SQL injection, raise your hand. Okay, so that's, I assume, the majority.
It was in the previous talk. So.
Ah, okay. So then I will switch to some lesser known issues, or I presume lesser known, like, for instance, server-side request forgery. Who has heard of that? Okay. Server-side request forgery. Okay, so not that many people. Okay. So in server-side request forgery, we have an attacker interacting with the server. So it's a server-side vulnerability. And the attacker tricks the server into sending a request to an arbitrary endpoint. And this can be used to extract sensitive information from the system. So the attacker will send this request to the server, and then the server will send another request to an arbitrary endpoint, get the content from this endpoint, and then send it back to the attacker. This issue, or this kind of issue, exists when when the server wants to fetch some remote content from somewhere, and this somewhere can be controlled by the attacker. And the things that, like when this type of issue is exploited, can lead to quite significant issues. So for instance, if the server is hosted on AWS, so the Amazon Web Services, they have like a specific endpoint where you can get the security credentials for those AWS instances. And if an attacker is able to leak these credentials, he can take over the server. So that's pretty bad. And also, there are several database services that provide REST interfaces. So that's basically communication over HTTP. And then the attacker can interact with these databases directly, or indirectly through this vulnerable server, and then leak information from these internal services. So to defend against these type of vulnerabilities, the main thing to do is to perform input validation. But unfortunately, so the server will need to verify that the contacted endpoint is valid. But to do this, they need to parse the URL. And URL parsing is quite tricky because, that's another thing of the web, is that it's very lenient to what developers do. So they want to be, like, if a developer makes a small mistake, then the website still needs to be working. And that's why we have a lot of issues on the web, such as this URL parsing. Because URLs, although the URLs we typically see are quite straightforward, they can be quite complex. So an example is like this https evil.com / or / at good.com. So which endpoint will be contacted if we parse this URL? And the answer is, it kind of depends on which parser you use. So if the code that is used to check whether this goes to good.com is different from the code that actually fetches the content, then it might be that the check says it's good.com, but the host that is contacted is evil.com. So it's quite tricky to perform these verifications. Yeah, the same with evil.com, and then in square brackets good.com. Like this square brackets is to support IPv6, so that needed a change in the standard of how the URLs look like, and many of the parsers or URL parsers didn't support it very well, so it will give different results based on the parsers. And then we can also do some more funky stuff in, so this HTTP and then this large number, like what will it connect to? And actually it will connect to this 169 IP address, because someone thought it's useful to change an IP address into an octal number. Why, I don't know, but someone thought it would be useful at some point. And there's many more examples of these URL parsing inconsistencies. So if you want to do it well, you have to be careful to do it correctly and not be very acceptable to what type of or how the URL can look like. So I will talk about one more server-side web vulnerability. It's called Unsafe Deserialization. And then I will move on to the client-side security issues. So this unsafe deserialization is caused because there are certain programming or several programming languages that allow objects to be serialized and deserialized. So for instance, Java, Python, PHP, Ruby, and so on. And so the serialization of an object turns this object into a string. And when you deserialize it, you take the string and turn this string back into an object. And that can be quite dangerous when the string is controlled by the adversary. Because then you kind of create this object where the properties are controlled by the attacker. And there may also be special functions called on this object during the lifetime of it. And that can cause certain unintended actions on arbitrary or attacker-controlled objects. And in order to exploit this, the attacker will typically need gadgets, so objects from other classes, to make such a successful exploitation. The consequences can be quite harsh, so it may eventually lead to remote code execution, but it kind of depends on which code is available during the execution or during the lifetime of this object. But there's been some research, and for instance for Java, someone created a tool called YSOSerial, which generates automatically many of these gadgets, or makes use of these gadgets, and then it automatically exploits such a service and obtains a remote code execution. So the defense is basically do not use this serialization and deserialization, or you can use an alternative such as JSON, and then create a object yourself such that it cannot have any unintended side effects. So I will show an example of a vulnerability that I found back in 2013, which was in the WordPress core. So WordPress is this content management system that is used by 25 or 30% of all the websites. So it's a very widespread thing. And well, it will kind of show that issues often don't come by themselves. So often you need to combine several smaller things in order to make one bigger vulnerability. So the issue was caused because, or WordPress was using these deserialization. So it's in PHP. WordPress is written in PHP, and in PHP, this serialization is with serialize and deserialization with unserialize. So WordPress wrote things for caching of meta information to the database. So when it wrote something to the database, it checked, or it ran the maybe serialize function. So it would serialize an object or array, or if if the content what was given to it was a string, then it would also serialize it if this if the is serialized of this string would return true. And they had to do this for compatibility reasons. They had to double serialize a serialized string. And then when the content was, or this cached meta information was read back from the database, it would unserialize this content if the if serialized of the string returned false. So in this case, a vulnerability would be there if first the is serialized of the string would return false, because if it would be true. So another thing that I should mention is that as an attacker, you can't just give objects to this maybe serialized function, because you can only send strings to the web server. On top, like the object or array part that kind of falls out, so you can only send a string. So you don't want this string to be serialized again, because when you deserialize a string, there's nothing really that you can do. So we want the first string that the attacker sends, we want the is serialized to be false. Then the string gets written to the database, and the string is again read from the database at a later point. So that's string 2. And then we want this string 2, or the is serialized function of this string 2 to return true. So basically, the storing and reading from the database should somehow alter the string, such that first is serialized will return false, and afterwards it will return true. So the is serialized function will return true if the string starts with one of these characters, so SAOBID, which stands for string, array, bool, and so on. And the string should end with a semicolon or a curly bracket. So in order to do this exploitation, we will use a special trick with UTF-8. So WordPress by default uses MySQL, and with a collation set to UTF-8. However, the MySQL's UTF-8 is not really UTF-8, but it's UTF-8 in the base plane. So the base plane are code points from 0 until FF in hexadecimal, but there's millions of other code points other than those. So when we try to insert something that a character that it falls outside of the base plane, MySQL will drop this character that it doesn't know how to represent in the database, and it will also drop everything that comes after it. So MySQL will not give like an error that it couldn't store this. It will just give a warning, which actually gets ignored in the PHP code. So an example of a character that falls outside of this base plane of UTF-8 is the pile of poo character. So as a side note, if you want full UTF-8 support in MySQL, you can use a different collation or character set called UTF-8 MB4. So I think it stands for that it uses 4 bytes to represent the data instead of 3. So to exploit this vulnerability, our payload looks a bit like this. So we have our serialized string, which is an object foo with a pile of poo added afterwards. So the is serialized of the string will return false because it does not end with the curly bracket or the semicolon, but instead this pile of poo character. And then when it gets stored into the database, the pile of poo character falls off, and then we have the is serialized of this second string, and this will this actually ends with the curly bracket. So this means that the serialized will return true, and then it will be unserialized, which causes a new foo object to be created. And on this foo object, there's a couple of special functions that are called. So to exploit this, well, unfortunately, there were not really any gadgets that I found in the WordPress base, but WordPress uses, or typical WordPress installations use many different plugins. And yeah, I found one example of a plugin where this issue could be abused into a remote code execution. So the final exploit looked like this, which would, here you would have whatever code the attacker wanted to run on the server. So that kind of wraps up the issues of the server side that I will be talking about. I won't have that much time to go over client-side security, but I want to just give away or give some information about the main core concept of client-side security, and that's the same origin policy. So the same origin policy states that site A can only access content from site A, and if it wants to access things from site B, it will be blocked. What it can do is send requests to site B, but it is not allowed to read out any of the responses. There are some things where we can have some interactions between these two sites, but those are guarded by the post message API. So the problem of many issues is with the fetch and XHR thing, that it allows requests to be sent, and there are several or many side channels that can be abused to learn some information about the response. Unfortunately, I won't have time to go in more detail, but if you want to learn more about it, come talk to me. There were some takeaways that I wanted to give, and that is that web security is not simply a client-side or a server-side story, but it covers both aspects. And often you may need to abuse multiple issues in order to actually exploit something. And another thing is what I often see in web security is that as there are new features, they will often introduce new vulnerabilities. So because a website supports requesting remote content or dynamically, it will lead to this server-side request forgery vulnerability. Because we want to have or want to serialize and deserialize objects, this will lead to unsafe deserialization. Then there are some things that I didn't talk about, so we can determine the size of a response, which will leak some information about it by abusing certain browser APIs. So when we introduce a new feature to the web or to a website even, we should always consider the security because it will often lead to many different issues. So there's also many different defenses that are there. Unfortunately, there's not a one defense fits all thing, but it's more of a whack-a-mole type of situation where we need a specific defense for a specific vulnerability. And sometimes we even need multiple defenses to eradicate a class of vulnerabilities. And it's becoming increasingly difficult to correctly apply all of these defenses across an entire website or entire company. So that concludes my presentation. If there's any questions, I'd be happy to take them.